Good morning, everybody. Now we are going to cover now we are going to talk about our new topic, which is our which is our core of Python, in which we will going to cover a comprehensive technical masterclass, in which we are going to cover our string, list, tuples, then sets, dictionary, and memory mechanics, and high performance coding practice. We are also going to do in our Python compiler online for our developers. So the scope of this class will be like comprehensive core data structures, and in which we are going to cover 6 modules completely. And the first one will be of strings in Python. So if we talk about strings in Python, if we talk about its pure definition, that is like a sequence of Unicode characters enclosed in a single small brackets, and a double small break comma will be apostrophe comma will be double, and the brackets will be small only. And we also can have a triple apostrophe comma in a single small bracket. So the properties, we talk about the properties of strings in Python. The first property is immutability, like it is cannot be changed. In string for Python, you cannot change uh, the uh, the data which you had the first you had put when you use, like here you can see S1 here and S2 here, hello and Python. These are the some strings we had created using codes. And this can't be changeable. The literal meaning of immutability is unchangeable. Once created, string objects cannot be altered in memory or modifying. A string creates a brand new object. If you are modifying your string like S1 to S2, if you are modifying it, it will become new uh, string. It will not be our as original string. If we talk about memory structures, so strings are indexed sequences starting from 0 to n minus 1, and support negative indexing as well. Like minus 1 to minus n it is possible, and from 0 to n minus 1 it is also possible. So here are some examples given. And if we talk about syntax of string, so the string will start and be from start in big bracket. First of all, we will write start, then stop, then our step, like our starting point, then ending point, and at the third point the third space we will write step. Like let's take an example, like we are going to from 0 to 100 by having skipping 2 numbers. So we will write it like start as 0, stop will be 100, and step will be 2. Or if we talk about negative index, negatively we are walking. So we will write here starting will be as 100, stopping will be as 0, and stepping will be as negative, more negative minus 1, minus 2, whatever we want, minus 50, minus 100, you can take anything. So start is an inclusive index and stop is an exclusive index. So here this is very important. Like if you are writing start and stop, you have to define the start will be included in that. Like if you are starting from 0 to 5, the 0 is included, and 5 will not be included. It will be included till 4 only. And step is like direction and stand length, which is default value of 1. It has always a default value of 1. Either you will write step or not. Only you can write is start and stop if you are adding by one step or one unit if you are increasing or decreasing. If not decreasing, you can't decrease. If you are decreasing, you have to write with its sign -1. And this is how it's happened. Here are the some examples have been given. Let's understand first of all the topic here. So we have covered steps till now. So if we talk about case transformation, like uppercase, lowercase, or title or capitalize, it can accept every kind of cases in letters. If we talk about searching and counting, you can use find, r find, or you can use count to count and start with and end with. By using start with and end with, you can count as well. If we talk about cleaning and formatting, so strip and replace and split and join is used for cleaning and formatting. We will understand it by further by example. So in F three dots are introduced in Python 3.6 for faster and more readable and allow inline evaluations like mean and score. Where equations and the numbers are formatting as students will understand by what we are doing. For example, so let's do the examples of this. While we will do solving our examples, we can easily understand the topic. Let us open our compiler, and then in compiler we are going to cover our topic. Like first was making a listing by a simple example as one let's say and say hello hello and then in S2 we will take as Python. Then we have a multi-line. We are using multi-line comments. So this is a multi-line string. You can see here. This is a multi-line string. And if we talk about its memory, which is its identity, which is an immutable. So we will write its text, which will be hello. It will be as hello. Then we do print by its ID as text, which will be text like this. Then we will write its text is equal to text plus. This is an example of concatenation as well. In which we combine two or more strings like this. Hello world will be printed, and then we will have our print statement, which will include our IDs, then text. Here we can see we are getting here the numbers of this. So here in this example, we can see here that we are getting different IP addresses for same, not same, but we have text here, and we again here have text variable with some assigned string, like in the first text, which have assigned value of string having hello, and in the second video or the second text we have text of previous plus text plus world. So here we have hello world and combined in the second text. So as we can see here, we have a different IP addresses for same text but different variables. So this is why we are having here two different types of uh, IP addresses. So if we want to remove this differentiability in both text, we need to remove the word here. If we remove this, and that also we have to remove. So after removing all these things, we will now able to get same IP address. This is happening because we have addresses. We have text this bit assigned as hello, and which is further again have text that is equal to text, and the text which is assigned the text value which has previously assigned a value as hello. So they all are operating on the same address. They are located at the same address. Because of that, they are having same IP addresses. But if I change something like here, we are adding like we are adding here buddy. So you can see here now we have changed this by adding buddy in the text. So these two are operating on the different IP addresses. This is because they are having different IP addresses. So if we don't want to know the IP address, we have that solution. We just remove ID, then we will get our normal constants like this. Here you can see that we are getting a hello buddy, and then hello buddy, and above that we have hello only. So here we have a multi-line text, multi-line string here. So we run this code. Here you can see we are having printing. Hello and hello buddy. Hello buddy printed here because we have another text where we add previous text plus in that text we are also adding plus buddy. So because of that we are getting hello buddy as our output. So if we print like multi line we will print our multi-line string and we will check whether it will all executed in a single line or it will also take multi-line as its own. So here we can see that it also taking that much lines of code. Like this is a hollow line, multi-line string. So this is something like same as it's told as a definition. So here we can add like we can have more of words like if we talk if we take this much words, if we copy from here and we just print it here and making it like this much line like this. Um, yeah, like this will be our placing it. We are getting the answer server like that. So here we are done. Here we have this has been done. Here we have different memory addresses. If we have two different identical things, but variables are the same, but they are storing different kind of attributes. So they are having different memory addresses. They are getting allocated on the basis of different fidelity. So if we talk about syntax of slide 2, that is indexing or slicing. So if we talk about indexing, it means we have positive or negative index. Like if we are stepping ahead of like in a positive way, we are adding plus one, plus two, plus three like this. It is an positive indexing. But if we talk about negative indexing, we are starting from backward ending point and we are getting to heading towards the starting point. Like this, we are the indexing. And if we talk about slicing, slicing is very important. We understand it like uh, skipping something. Like we have a list of information. 10 information like we have. If we are we are extracting first information, then fourth, then seventh, then nine. Like this kind of extractions we are doing. We are just getting those numbers, and by this is happened because of indexing. And if we talk about slicing, is like something we are cutting out of part, like we are skipping first four things, or we are skipping in between those lines, like four to five or four to eight we are skipping, or we are just removing last part, like we are not extracting the information from eight or eight to ten, like this we are doing. That is known as slicing. So here also we have some information. Have message like in a string form as Python programming. So if we talk about positive and negative injection, is like in message we are using message and we are sorting it from starting from zero. We are just extracting our zero position value, which is P in here Python. If we talk about minus one, we have uh, we are making we are expecting minus one position value, which is at G, which is G. So here we are getting output as C and D. If we talk about slicing is more often like we are just expecting that much which is required, like 0 to 6, it will include Python. And if we have 7 to infinite, then it will be programming because Python is of 6 words, then we have a space which will be 7, and after 7, that will be our programming. So after 7, if we are printing, we are getting programming. And if we talk about printing message of uh, space, nothing will be there, and then semicolon, then again semicolon, then two. Here, what is happening is just like starting point not declared, ending point not defined, and our step which we have to take. That means the numbers of information which we have to ignore, or we can say skip, is defined. Like we have to take information, then skip, then information. Like this, we have stepping of two. After every second character, it will pop up or it will we talk about print message, then starting point and ending point is not declared, but we have a minus one of steps. That means it will start from negative side and it will go to from ending to starting in descending order, like this had been printed as uh, uh, Python programming is now converted into GNI double MARGORP, and Python is now reversed into NOSPYP, like this. If we talk about here, the slide 1.2, what is written here is like syntax, then start, stop, and step. Let's understand what does it mean. The syntax is like the string name which we have to print, then we will have start, then semicolon, then stop, then again semicolon, then we have to write step what we have to take. And if we talk about start is an inclusive index. That means the first we need our ending to starting in a bracket. That means we will include our starting points. Like here, it will write 7 to 8. 7 will be included, but 8 will not be included. That means starting point will be included index, and a stopping point, that means ending point, will be exclusive index. That means they will not be included. We talk about the steps. So steps decide the direction and stride length. That means they which will have default value of 1. That means if we are not giving the step, like we are not giving the direction, the default value will be 1 and it will ahead by 1 without skipping any value. Yeah, so here in the slide we have case transformation, that is upper, lower, or your title and capitalize. And if we talk about searching and counting, we have a functions to search like find, rfind, and then count, and start with, then end with. And if we talk about cleaning on and formatting, we have dot strip, replace, and split and join. So let's do the examples of these, and after that we will do the example for cleaning the dirty data. Yes. Here is our Python compiler. Here we will write a message in string form that will be uh, I I Lucknow, like this kind of string we have. Then uh, we will first of all let's write what we have to do. Like we have to do positive and negative indexing first. We will do positive and then we will do negative indexing. And after that, we will write it like that. The message will be from like if we are doing for a positive indexing, then we will start with zero. We are just extracting one information like zeroth value, which will be I will be printed. Like here, if we do this, you can see here. Where do you network here? Where you will follow my network. Let us open it in VS Code. It's simply write in reverse indexing, that is negative indexing. That will be like message. Then we will start with our -1. And let's say that it is run or not. It is running. Let's say it is saying 3050 first of all. Then I will, so here you can see that there was not of network problem. There was just a mistake here. It was completely fine. Like it was printing the I here, the first letter. And if we write, if we want to print our message in opposite in the negative indexing by writing -1, then it will be completely fine and will be give the last value. Like that we can print any kind of value. For example, if we are printing a message and then the number of position number, let's say 7, then let's see what will be the result here. Here you can see there is a seventh number letter, so it's getting printed. Let's take another example, like we are going to print message of let's say fourth letter. Let's see what will be the output. So B is our fourth letter, so it's getting printed. So like that, we have another example. We have slicing topic, and we have its example. So let's understand this topic one by one. So first of all, we will just print the Python word. We will print two sentences. For that, we have to write print, then message, then we have to give starting value, and then we will be like 4, 5, we will give 6 as ending value. Then we will be able to write that much total 6 value. We will print till like message, then we will start from 0 and then we will go to 6, 7, 8, 9, 10, 10th value. Let's see what will be the output. Will be C2, will be the output 11, then it will be luck, I love luck, and then we will write print, then message, then we will not give ending value. Let's see what will be the output. The flow will be the output here for. So if we want to write from bottom, uh, if we want to write love Lucknow, then we have to start from third index. So let's print this thing, then the message, then will be our third to we will not define. So we have to write it from the second one. Here we can see we are writing able to write after I, that is love Lucknow. Then we will have another example. Now we are going to print our message. It will be start from 7. Let's say 7 and we until Lucknow. Whole Lucknow will be printed. But if we write like message and if we want to skip one word after one word, then we can do it as well. We will not assign starting value and nor will be the ending value. We will just skip step to which it goes wants to be forward. So we can see here we are able to write here. Like this, we have another example in which we are going to print our message. from, let's say, we are heading to 4 by 4 minutes. Now we are half on way. Like this, we can also have a reverse order. Like if we don't assign starting value and then not assign ending value, we will just assign negative step. So it will reverse the order and goes till now. Now, then if we want to print it like the print message, and then if we want to print form, so let's say starting point will be our 7 and ending point will be our like we will modify and then we will give it a reverse order. Here you can see that starting from L, then we have a reverse order like E, D, O, L, and then in last we have I. Like that we can get output as well. So it be another example could be like message. Then we will have not assigning our starting value, but we will assign our ending value as 6 and our descending order. So we will now able to see that LUC KMOW is now in reverse order. So this is how it is done. So let's do this example of clean dirty data. So let us understand it one by one. So we will write what we are going to do. So we are going to we are going to cleaning the data, cleaning dirty data. Then we have raw input in the form of a string. We will have a user name @ email.com, and then we will have slash like that will be have. We will have a clean input, then we will have a raw input, then we will have write strict raw input strict, then in bracket we will have a lower then bracket. After that we will print our clean input input. Like that, after doing that, what we will get is like username, username @gmail.com, email.com. This is this is what we have to clean. So after that, what we have to do is like we have to split and join it. So before doing splitting and joining, we are going to execute this code. Let's see what happens. Here we can see that we are able to see username @email.com. Here we had spaces which had been removed, and this is the output we will get after cleaning the dirty data which is not required. So for splitting we need our string. Let's make it by using curly braces. The specific word will be in big brackets, not curly. So then after that, let's say example Python. Then after that is awesome. Then after that we will write a sentence that will be equal to like this after like join word. After that we will print after that we will print this message that sentence and we will see able to see that that sentence is going to be printed. Python is awesome. So we are going to see that Python is awesome. So they remove these things as and like this we are doing. Now we will able to see that this is have been joined. That's how we can join anything. And if we want to resplit it, then we have our code as resplit as resplit that will be equal to sentence dot split will be like this. And after that we will print it print then resplit. What happened then like it will be splitted as like it will be splitted again like we have taken 11 then 10 then we will get our number as 2011. Like this we are able to get the number in splitted. Or if we take the example of previous example of Python is a reason costly, then we have to write words equal to then in big brackets we will have our first word as Python, Python, and then we will write that is after that awesome. Then after that we will first of all we will join them. So for that we will write something will be equal to dot join word, and then then we will print the sentence. After that, we will going to recreate it. Sentence dot split, and we will print split. That's how we can do. Python is awesome that is in join form, and then again it will be splitted in different, like in order wise they are splitted. We're going to cover the topics of tuples in Python. So if we talk about its definition, so tuples is immutable. That means they are not changeable, and they are in order form. That means they are in sorted form. They are arranged in ascending or descending, increasing or decreasing order. And the third point is collections. So tuples is also carry collections of data. And if we talk about syntax, it is defined using parentheses, like small brackets. If we talk about performance, with compared to list, so tuples are slightly faster than list for iteration and access. And we talk about data integrity. So tuples guarantees the data cannot be modified accidentally. That is what written in the above definition, that it is immutable. So it cannot be changed, and tuple give the guarantee that it will not be changed. So if we talk about dictionary keys, so this can be used as keys in dictionaries if all the element inside are hashable. So dictionary key is used to access the values or access the elements which are accessible or hashable inside the dictionary of tuple. There's a code given here. So if we write this code and let's see what happened here. Here what we have written is single item, and here we have 42 in the tuple, and in a not tuple we also have 42, not a tuple. That is a plain integer. If we point as 10 comma 20, then it will, let me see whether it is, if we will point 10 comma 20 at point 0, it will raise 15. This is because it will calculate its average value, and it will, after that it will raise error like this. It will not give any output. This also can be happen. So in the second part we have packing, like how does characters are being put inside tuple. So assigning multiple values to a single variable without explicit parentheses. So here we are going to know that we don't need any extra parentheses. We can assign multiple values to a single variable without parentheses or brackets like that. That is in packing. Or if we talk about unpacking, so extracting tuple values into individual variables. Like in the tuple, we have collections of data. We extract them into individual values to the individual variables. Like here in the example, tuple packing is like we have these kinds of multiple information in a single variable assigned, And in unpacking of the tuple, we have name, age, and job. Then we have person, name. That means here we can see that they are assigned into individual values. So we talk about extend unpacking. This uses star to capture remaining elements. Like here we can see first, then middle, which is a star in the middle, and then last. That is equal to our data. If we want to print the first, then we can print it like this. In the middle, we have 2, 3, 4, 5, which is also getting printed. And in the last, it is also printing 6, which is at the last of the in the tuples. If we will run this code, we can see Elias is an engineer. We have assigned here values to a variable and then name a job as this of a person. So here we are printing name and is a job and job name, that is engineer. So we can get the uh, output as Elias is an engineer. And if we talk about uh, second thing, that is as extended unpacking. Here we can see we have a data, and in that data we have collections of information or values, and we are assigning first, second, first, middle, and the last. And in that, if we are printing these things, we are now able to get in the first, we are getting first value, in the second value, remaining part like excluding one, first value and excluding last value, we are able to print the whole value, whole set of values in the middle, and in the last we are able to print here 6. This is what here written as well. So here we have some questions like write a Python function to swap two numbers using tuple packing and unpacking, and then we will have given list of a tuple containing student names and their scores, and they will be sorted in the list in descending orders according to their scores. And in the advanced, we will going to cover a question which will say that explain why a tuple t equal to 1, 2, and then in the big breakers 3, 4 can have its list element modified as a form of t in the big breaker 2 dot append 5, but still remain immutable overall. So let's do our first solution, first question. So here we have assigned value of a equal to 20 and b equal to a equal to 10 and b equal to 20, and now we have a comma b equal to b comma a, and then if we are printing these numbers, now we are able to see that the numbers have been reversed, swapped. Like here we are able to see that we firstly assigned value of a as 10 and b as 20, but in the second station we have swapped these values of a and b by a equal to b and b equal to a. And then after swapping, we are printing these values of a and b, and we can see that the values have been swapped. So the first has been done, and the second is given this container containing student names and then their scores that we have to sort in a list in a descending order. So we have students and their score along with their score, and we have to write our code like this. We have a student. First to the student is Alice with 88 marks, and then Bob with 95 marks, and we have Charlie. with 78 marks. Then we have to sort student and sort its students. Key will be lambda, in which x will be 1 and reverse will be true condition. So we will sort according to the reverse condition. The sorted student in the descending order will be like Bob with 95, then Elise with 88, and then Charlie will be at 78. As by this code we can see our results have been changed in descending order. They got printed in descending order. Like the student Bob had got the highest marks, and then Charlie with second number, and then Elise with second position, and the Charlie at the last with the lesser marks than everybody. So here in the modify or append, we have to see the questions of that. So if we do this code here, here we have a tuple of 1 comma 2, and in that tuple we have another list of 3 and 4. If we are trying to append the positional value of 2 by 5, let's see what happens. Append is used to add something, and in the tuple, append is used to add. Here we have a tuple T with 1 comma 2 comma 3 comma 4, and at the zeroth position we have 1, at the first position we have 2, and at the second position we have a list of 3 and 4. So if we are appending at position 2 or adding at position 2 5, so we will not add in the list of 1 comma 2. We will tuple we will not add in the tuple of 1 comma 2. We will the 5 will be added in the list which is in the tuple as after 3 comma 4, that will be equal to 5. So we will process this data. You can see here the zeroth position has not changed and the first position has not changed, but the second position we have a list of collections of values here like 3, 4, 5. So if we have done this as well. By this you can see here our tuple is immutable because in the tuple we have three numbers only, three values only. At the first we have single, then second as we again have individual value, but at the third we have an individual list. List is mutable, but tuple is not mutable because we are not adding in the tuple, we are adding in the list inside the tuple. So let's now understand the topic of set. So if we talk about its definition is unordered collection of unique and hashable elements. So if we understand what the unordered collection of unique means is, like we don't have a predefined or order like in ascending or descending or in bigger or smaller. Like that, it is not ordered, and every item will be unique. We cannot repeat it. If we have uh, set of data which is not unique, we have repeating numbers or data collection or information. Then if we will print these numbers, we will get only unique numbers. And hashable element means we can access those elements. So here no duplicate values are allowed as it is written here. It is a unique collection of another information or data. So it is there will be no duplicate values in there. So in union text cannot access set 0. So here we cannot access set of 0. We have to write it from 1 to n. So it is extremely fast membership testing, 0 1 average time complexity. So it is one of the fastest testing here in time complexity of 0 of 1. That is its average time complexity. Here we can do union as well, like union of A and B by using a syntax of dot union. And then we have our intersections as well, like A and B. And this can be done by syntax writing as dot intersection and then will be bracket. And we can also difference in two sets, like we have set A, set B. If we want to if we want to find union, and if we let's talk about union, what does it mean? Is like collection of both A and B in excluding A intersection B. That means A will be shown, B will be shown, and the matching part in between those will not be shown, but that will be covered in A and B. And if we talk about intersection, is like the common part in between them that will be printed, and difference A minus B can be found by writing syntax as dot difference. So symmetric difference is like A, then that symbol that like this can be written as dot symmetric underscore difference. So here we can get the difference in between them. If we are writing A minus B, then the common part will be subtracted from it, and the remaining part will be written as same. This is more often like A union B, in which we are removing A intersection twice time. This happen in symmetric difference. And we have some questions here like write a Python script that takes two lists and returns the list item which is common to both. That means we have to write intersection, and then we have a given list of words, and we have to determine if any of two words are anagrams of each other. So if we talk about what does anagram mean, so lower to upper sorted like that. And we in advanced question we have to write a program to check if a string contains every letter of alphabet like panagram. So let's do the question. First of all, we will do this question. Then after that, we will be doing every question of this. So here we have def and the common element in L1 and L2. Here we have set of L1 and set of L2. If we print this, we will not get any output because we have not defined any list like that, set like that. So to do that, we need a set. Here we take this set to solve this question. Mm, let's understand why it is not giving output. We will check here. Like this, we can give it to like this. We can get our sets being printed. Here we have a set of 1, 2, 3, 4, and set 2 of 3, 4, 5, 6, and we have to find common elements in both them, and we have to return this list of set 1 and set 2, and then result will be common element of set 1 and set 2. Then we will print this, and we will able to see the common elements are 3 and 4 in them. Like here we have 3, 4, and here in the set 1 And set 2 we have 3 and 4. So here in the second question we will write here as this diagram and sorted. So let's do our first questions of sets. Like here we are going to create it. We have an empty set and numbers 1, 2, 3, 4, and then we will print a number. You can see here we are only able to print the numbers which are unique. If the numbers are repeating, that will be ignored after a once it gets printed for the first time. In the second example, we have our like set 1 and set 2. And in set 1, we have 1, 2, 3, 4. And in the set 2, we have 3, 4, 5, 6. And here we are printing set 1. Uh, we are printing first of all unions. Then we are printing intersection using and difference using negative sign that A minus B, finding difference of A and B. And then we have a symmetric difference, set A of and set B having a symmetric difference of 1, 2, 3, 1, 2, and 4, 5 because 3 and 4 are common in both them. So we will print this statement. Here we can see in the union part is like 1, 2, 3, 4, 5, 6 is the union part, and 3 and 4 are common in them, and 1 and 2 are the difference between A and B. And if we talk about what was that is the symmetric difference in between them was 1, 2, and 5, 6 because 3 and 4 were common in them. So symmetric difference will be only different elements in them. So here we have our Python dictionary. So if we talk about Python dictionaries, so it is defined as key value pair with 0, 1 with an average lookup of insertion and deletion time. So here we have firstly we have a key, and then a key will have an assigned value, and the both will be in used as in pair. And then we have an average lookup here, and we can uh, insert something and delete something in both of the values of pairs. So rules are like they must be hashable and immutable, like string, numbers, and tuples. These are immutables. And if we talk about ordering, as the Python 3.7 plus suggests that dictionaries maintain insertion orders only. So if we talk about methods to do something, like if we want to add keys, then we have dot keys, and if we want to insert values in that, we have value. If we want to add items, we have items and dot pop. Or if we want to something update something, we have dot update in that. If we talk about collections and default dictionaries, a so provide a default value for a key access when a key does not exist. So we have a default key value for accessing any variable key value pair. So from collections, it will import default dict and counter. Count will be as counter and abracadabra as abracadabra. And then we will print the count with the most common, which is 2. And we will be doing as merging two dictionaries and sum of values of overlapping keys, count word and frequency in a string. and in word dictionaries in a group of duplicate. Well, first of all, we will going to do first example here. Here we can see that we have a user and we have its key and its value. So we have a user with a variable and we have assigned a value key which is 101 and then we have a username and keys for it coder 123. So if we want to print here user.get, we are printing here email not provided. So if we want to print the email, we have not provided email, so it is not providing, and here we can see our code is working properly as not provided. So here in the second code will be like we have a score and a key and a value, and then we have again a key and value. So for key value in score dot item, so we have to print the key and the value. So let's run code. So here we can see that here the keys are at Alice with value of 90 and Bob with value of 85 has been printed here using key and value pair. So here in the third question, from the collection import default dict encounter, we can see here it is adding default values like A and 5 and B and 2. So these questions should be done by yourself. The third solution of third, that is invert a dictionary and a group duplicates value into list. So that thing I will going to do here, solve here like this. We don't have inverted any dictionary, so we are not able to print this. We can do in further classes. So we talk about comparative analysis and final challenges between them is the first thing about is mutability versus immutability. So if we talk about list, set, and dictionaries, these are something which can be modified or these are like mutables, while string and tuples cannot be changed once it has been allocated. That means if we have list of data or a set of data or we have dictionary of data, we can modify them. We can add, update, subtract in between in them. But if we have a tuple or string, we cannot add them. We cannot add any we cannot add any identical number, value, or like string in them. Once it has been allocated, like a is equal to Abhinav, that has been allocated as a string that cannot be changed. Same as in tuple, also it also happens same thing. So ordering will be like list, then tuples, string and dictionaries that preserve item in order. Sets are completely unordered that we had understand here in a sets like Python in sets. They are unordered collection of unique set. That is what it has written here. Sets are completely unordered. And if we talk about duplicacy, here list, tuple, and string permits duplicate elements, but sets and dictionaries key discards a duplicate automatically. Because in set we don't have duplicate value, and in dictionary we have key value pair. So key value pair cannot be duplicate because they can access only one data using one key, and so because of that we automatically Duplicates will be discarded in sets and key dictionaries. So here we have a demonstration of core behavioral difference, mutability check in list and tuple and set. So let's see what happens. Here we have my list as 1, 2, 3, and then we have my list assessing value 0, which will be allowed. Here in my list, at 0 will be 99. That will be allowed. We just have to write print my list. Then we will able to see that 99 has been updated in place of 1 at position 0. In tuple, we have tuple 1, 2, 3, and my tuple at 0 is 99. Here will be execute or like we will print this. Then we have a type of error that will be tuple. Object does not support item assignment, so that we will not going to do. But let's see what happens. My tuple, different my tuple. Here it cannot be changed, so here we are getting an error. Because of that, we will not be writing here. Third example, we have set. Here we have my set as 1 comma 2 comma 2 then 3 comma 3. Like we have duplicates as well. If we print my set, then we will able to see that duplicates of 2 and 3 has been removed. So this is the key difference between them. So here we have choose when we have to choose what kind of set of data. So we have to choose list when you have an ordered collection of items that will change frequently over time. So you can use list. List will be the better option here. And when we have to we should choose couple when your data is represented in a fixed record or coordinate or read it and or read only by grouping. This time, this kind of problem, you have to choose tuple and you have to choose set when you have a uniqueness and lightning fast membership testing like the dollar zero or $1 are your primary priorities. So choose dictionaries when you need fast index lookups based on descriptive unique keys. Here we have some problem. Let's do it quickly. Here we can see we have a database of configuration. We have a local host, and then we have a visitor IPS. We are thinking different. Write a function to analyze a log of data log that process a raw servers and log to a stack IP. This problem can be done by yourself, and that's all for this video. Let's understand something. Let's start doing these problems. Here we are defining and analyze the data using logs, and then we will analyze, and we will further use for loop in logs to check log in logs. And then we have our IP and endpoint as log.split. And if IP is not in analysis, we will analyze the IP as total hints and unique endpoints and sets. Then we have analysis of IP as total hits and plus equal to 1. And after that, analysis of IP in a unique endpoint dot add an endpoint that will return analysis. After that, we will print this. Analysis is not holding defined. So this has been done for today.